Okay, we have a motor that can provide a maximum torque of 110 Newton meters. Assuming that all of this torque is used to accelerate a solid uniform flywheel, which is a cylinder, of mass 10 kilograms and radius 3 meters, how long will it take for the flywheel to accelerate from rest to 6.58 radians per second? So 6.58 radians per second, what is that? Angular velocity. Exactly right. So we want to go from an initial angular velocity of 0 to a final angular velocity of 6.58 radians per second. We want to know how much time it takes to do that, how long it will take. Well, kinematic equations, if we have, I'm assuming this is a constant torque as well, if we have a constant torque, that will result in a constant angular acceleration. We have an equation that will relate omega naught to time by way of angular acceleration. So we need to figure out the angular acceleration in order to find the time. We know that's 0, so the time will be simply this final angular velocity over the angular acceleration. So torque. To relate torque to acceleration, angular acceleration, is Newton's second law. We know the net torque acting on an object is equal to the moment of inertia of our object times the angular acceleration. So we're given the torque. The torque's 110 Newton meters. Moment of inertia we need, and we will be able to solve for the angular acceleration. So moment of inertia of a solid uniform flywheel. You got to look on the table. Solid cylinder, basically. The moment of inertia for a solid cylinder is 1/2 mr squared. So 1/2 times the mass, which is 10 kilograms, times the radius, which is 3 meters squared. We can solve for alpha. Alpha is the angular acceleration. So bringing this over, we find the angular acceleration to be 2.44 radians per second squared. By the way, what are the units on moment of inertia?
Fourth or something. Meters to the fourth.
Don't make this harder than it is. What values are you multiplying together to get moment of inertia? So what are the units of moment of inertia? Kilograms, meters squared. Exactly right. Remember, a Newton is a kilogram times a meter over second squared. So this is basically kilogram meter squared over second squared. So the kilogram and the meter squared are canceling, leaving us with second squared. The radians are implied. Okay. By the way, whenever you use this equation, alpha always has to have units of radians per second squared. Can't be in anything else. But now that we have it, we know omega was 6.58 radians per second. Alpha, we just figured out, was 2.44 radians per second squared. So the time ends up being 2.7 seconds. Now, of course, we're assuming that that 110 Newton meter torque is constantly applied. We're assuming that's not changing, which I think is a fair assumption.